Oh, look at that. There's a short right there. So let me grind away some of the thicker parts. Oh, here we go. If your iPhone died after a backglass repair, this is what you need to know about what happened and how to fix it. This is a 13 Pro Max that went to a repair shop to repair the broken back glass. And if you look at the inside of the metal frame, you can see these little spikes. These are dents from a tool called the back glass breaking tool. This is basically a spring-loaded hammer that you press down and it slams the glass, because what you want to do is you want to crack the glass. It makes it a lot easier to peel off when you're doing the repair. And this is what repair shops do when they're doing the repair. They don't take any of the parts inside out. They just leave it fully assembled. And then this motherboard, it sits around here. And if you look what's underneath, there's a bunch of dents. So this corresponds to this section here. So if you're doing the 13 Pro Max, you got to be careful when using that tool in this area. It is typically recommended to only really use it around the cameras, because that is the toughest part to get off. The rest can be done with the laser or hot air. You got to be real careful about doing this repair when you leave all the internals. It's technically better to just remove everything out, at least the battery, the cameras, and the motherboard. That way you don't cause any problems. Some other problems are also just damaging the charging port flex down here, which kind of runs along the bottom of the frame, or the flash as well. It gets damaged often. So all kinds of problems could happen during back glass repair. In this specific example, we're going to go over this 13 Pro Max motherboard that does not turn on. And before we get started with the diagnostics, I do want to let you know that we do offer mail-in service for this repair and for data recovery. Send me a message through my website. I have it linked right there at the bottom of the screen. So let's go ahead and get started. First thing we want to do is check the board only with the DC power supply. This is a boot cable for the 13 specifically. So I'm going to turn this off. I'm going to plug it in, and then nothing else plugged in. So when you have other stuff plugged in, you are adding variables. What we want to do first is rule out the motherboard. Is the motherboard the issue, or is it somewhere here? Best way to do that is with this. So I'm going to push power, and we have an instant 2.5 amp draw. We should not have any current draw before we prompt to boot. This is bad. We're leaking 2 plus amps somewhere on the motherboard. So next step is, let's figure out where is this short located. So whenever you have a short before you prompt to boot, it's going to be on VDD main or VDD boost or a few other lines, but those are the most common. So we have a short on one of those 2 lines, and we're going to pull up ZXW, and this is going to show us basically all the connections on the motherboard. The easiest way to find VDD main on a board like this, where it does not have net names, is find the PMIC. Usually it's a big chip like this, and it has a bunch of coils like you see here. And then you click on any surrounding component, and if you click on something and it highlights 90% of the components, then that's VDD main. So now we got to find somewhere to probe it on this motherboard. This is the inside of the sandwich. Let's go to the outside of it, and it looks like on the top side of the board, this is under a shield, so we can't check there. This, I'm pretty sure this is all underfilled, so that's not an easy spot to check. This is under a shield. This is all under a shield here, but I do see some components here. This is probably the easiest one to spot. So let's go under the microscope. All right, so first let's get rid of this foam here. We need to be able to visually inspect the board. And it looks like pretty much all the components are underfilled here as well. So let's find something a little easier to spot. So this big cap here between the 2 connectors and the 2 horizontal caps. So basically this one here. And it's going to be the bottom side. So there you go. We expose the cap from under the underfill. That one there. Put our multimeter into diode mode. This is a very important step. Diode mode allows us to measure the line, and we can see if it's shorted. So red probe is going to go on ground, so like the screw post here. Black probe, look at that, 0.002. This is typically around 300. We have 002. So basically 0.300, not 0.300 in diode mode. So basically, and diode mode is actually in volts. So we have 2 millivolts. It should be 300 something millivolts. So we definitely have a short on main. Next step is, now that we confirmed that we have a short, we can use the thermal camera to try to narrow down where the issue might be. Although, you know what? Let's peel off all the stickers and everything so we could see better. Thermal camera cannot see through. It's not an X-ray camera. So let's get rid of whatever we can. Like this foam and all the stickers as well. Not all of them. These stickers, these foams are technically to help with water resistance from what I can tell, which I think they do. They do a decent job of keeping some water out of there. And since we're most likely going to have to split this sandwich board, let's get rid of these while we're at it. Well, we don't need the top side exposed. Okay, there's none on the other side, and then the bottom side as well. Now this is the side where it experienced some impacts. And you can see, looks like they used a laser machine because you see all this dust, all this black dust. So yeah, using the laser machine is very messy. I personally have one, but I only use it a handful of times. I find housing swaps are a lot easier, and usually customers are willing to wait for OEM housing. Now, back glass is a more cost-effective option for doing a repair. You could stock pretty much every color for only a few $100s, and then whereas keeping a housing for every single model is just not practical. Oh, look at this. Looks like the other shop must have damaged this. So because the 5G flex is torn, we're going to have to remove it completely. This creates a short as well. So I don't want to add that as a variable. So typically, if this wasn't ripped, you just remove this one here. Yeah, so one of the biggest mistakes people make when they're disassembling these phones is they don't realize the US models have these 5G flexes, and the main reason why most people tear them is because everyone's watching the Chinese teardown videos, which they don't have them anywhere except for the US. So in China they don't have this, so people don't show this part of the teardown, and people just assume that their board doesn't have it either. So yeah, so this is torn. We'll have to replace it at the very end. So what I do is just yank it off and throw this away, and I have more in stock. Depending on how long the video is, you know, whether I'll show how to replace it. Now, the nice thing about, not nice, but the thing you can do about this is when you peel it off, it's not going to cause any more shorts because you're just lifting up stuff. It's not going to bridge anything in the process. So as long as you rip off the big chunks, you'll be good. None of these are connections to each other. So we're good. So let's go back. Oh yeah, and like I said, I got rid of all the stickers. And looking at it from the side, I don't see any dents. One of the problems with this issue, maybe right here. Somewhere there you can see kind of the light warping a little bit. Now there is a natural dent somewhere around here that all the boards have. But there's some cases where you see giant dents in the board. That's when they go really rough on the housing and don't realize they're slamming the board. One of the scenarios is if the bottom board is physically damaged like that, you're more likely to require what is called a bottom board swap. This is where we take the top board, which is the main board, and then the bottom board, we swap over the paired chips. So baseband CPU, Wi-Fi, and baseband EEPROM onto a working board, and then to get it all working. So that's a whole other process. I'm not going to show that here, but let me know down below in the comments if you guys want to see bottom board swap videos for the 13 series. Maybe drop a number 1 in the comments if you want to see that. All right, so let's plug it in and then bring out the thermal camera, and let's see where's that heat emanating from. So I'm going to raise this up a little bit, refocus the lens. All right, I'm out of focus. All right, so I'm just doing this for the video. Typically this is facing me, but let's push power. We have the 2.5 amps being drawn, and you see this is heat. This is the charging IC. The battery this is connected to the battery connector, and it feeds through the charging IC to main. So that is normal. Let's ignore that for a second, and then we'll come back and show you another way to do this. Oh, look at that. There's a short right there. There might be 2. There's a big spot here, and there's something there. So, and that's probably the heat from the charging IC on the other side. All right, so that heat is seeping through the other side, but there's definitely something there. That is typically baseband PMU. This is the baseband power chip that powers the baseband circuit, and it's very common after the back glass repair to shatter that chip. For whatever reason, it wants to shatter. It shatters very easily. So we pretty much found our fault. But there's another way. Now, if you don't have a DC power supply boot cable, you could technically inject directly into VDD MAIN. So here I have VDD MAIN selected, right? So the components around PMIC all light up, and then majority of the board is lit up. Now go to the bottom board. There's basically 2 test points here and 2 points here as well, and then this dot here. So let's take a look at the board, see which is the most easiest to spot. And it looks like it's going to be these 2 right here. So if you match that up with those over there, with these right here, it's going to be these right here. Both of them. So either one. So this is just an alternative method to do the same thing. I have my DC power supply right below me in the video, but it's physically above me. And then I have extension cables here that I'm going to plug into some multimeter probes. So these are connected to the DC power supply. It was set to 4.2 volts and 2.5 amps. So when I short these together, you're going to get 3 amps actually. It doesn't matter. So basically use those settings, 4.2 and 3 amps. Then basically this is what we're going to do. We're going to inject into these lines. So the black one goes into ground, so you can touch something metal like this, and the red one you touch one of those 2 points. So that's what we're going to do under the thermal camera to spot, to see where is that heat coming from. So you're going to have to do this and like check multiple spots. We already know where it's at, so let's see if we could spot it. Look at the amps. So right now it's 0 amps and 4.2 volts, and then when I touch those points, we get the 1.5 amp draw, and you can see where it heats up. Actually, this is also sometimes easier. Oh, actually, there's a metal thing here. Let's see if this works. Yep, you can see the short right there. So if you're having trouble finding it, just keep moving it and repeating the steps until you spot where the heat. Your probes are going to heat up because that's kind of where the power is flowing through. So sometimes, depends. But in this case, you can see the heat is going to be in the same spot. So this is another option. Now, only inject 4.2 volts and 3 amps into VDD MAIN. Do not do it into other random lines, because you can kill those chips that are attached on those lines. So now the next step is to hit the like button if you guys are enjoying this video, and subscribe to the channel if you want to see more videos like this. Because I'm now going to show you how to split the motherboard. So this is the I2C T20 heater with the 13 series plate, and you can buy this with the links down below. Currently, I only know of China that has it. A few things that I like about it is that it has interchangeable plates, it has voice commands, and the plates are flat. So the models that have the 5G flex do not get blocked by the plates. Some of the other heaters, the plates are in the shape of the board, which prevents the flex from entering, because these tools are designed in China, and like I said, China's phones do not have that 5G flex. So when they design tools for it, they don't take that into consideration. Whereas this one did, and there is no obstruction for the flex. Also, what I like about it is it has a fan. So if you hold both of these buttons together, it turns on the fan and cools it down. What we're gonna do now is heat it up to about 210. When it's red, it means it's heating, and you turn on the heat by holding right. Or you say, hey buddy.
Hi, what can I help you?
Turn on the heater.
Okay, the temperature will rise to 200 degrees.
Yeah, so you can use the voice command to turn on the heat, to turn on the fan.
The temperature will rise to 200 degrees.
So it can sometimes get confused that it thinks you're talking to it. So it could talk, get temperature, fans, turn off the heat. You get.
Okay, the heat has lifted off.
Yeah, so it heard me say it. So you could turn that off as well. So if you don't want to get spied on by the Chinese factories. All right, so while it's over 100 degrees, what I like to do is feed it flux on the sides, because you want a nice solder joint when you split it, and you get that by adding flux. So I'll just feed it here on the sides. Basically, I'm like injecting flux onto the side. Now this is the top side of the interposer. And by the way, don't use my temperatures as your temperatures. You should, if you're gonna get one of these tools, make sure you guys are practicing and checking what is the right temperature for your heater, because they're not all the same. My other heater, I would have to go to like 230. This one I can go to like 210. You know, it varies. I've seen some people say they put it at 180 and it like destroyed it. So keep that in mind. Don't try this at home if you don't know how to do any of this. Do not do this as your first repair ever. As far as a micro soldering type of job, it is not for the faint of heart. It is a advanced skill, and it requires a lot of practice and all the right tools. You cannot do this with a hair dryer or anything like that. All right, so we're reaching the melting point. I'm gonna see if it's splitting. Usually this bottom side splits first, like the weakest point. Another thing I like about this heater is these little fingers. They can hold the board down for you, whereas some of the other heaters do not have this. Now, one thing, if I'm impatient like I am right now, is I can use hot air as well to split it. So while it's at the temperature I set it to, you can use a little bit of hot air on top to assist with reaching the temperature points. All right, so let's take a look. I'm still not feeling it separate. This side is probably already allowed to split. Let's see. Oh no, not yet. One thing I like to do also is just kind of press down on the metal shields or the screw posts. Help promote heat transfer. All right, so it's still not splitting. So I'm gonna use 360 and 40% air, and basically just kind of heat around the perimeter. The key here is to keep your hot air moving. Do not just keep it steady in one point, or you're gonna damage the board. You're gonna float the CPU or bump components or do something that shouldn't happen. So right now, what I'm doing is this part is the easiest part to split. So yep, I got my tweezer under there. So now I'm gonna spread the heat in the other areas. And what I like to do is just go left and right, and then gently keep sliding my tweezer, but I'm staying in line with the edge of the, see how my tweezer is like up against the sim? I don't want to put my tweezer anywhere in between the board or underneath the board where it could be components nearby. Now I'm going to let go. I'm going to see if I could get in on this corner here on the bottom side. I can feel it separating. Now, one reason why why it's kind of better to use hot air is because the hot air is heating the top side. If you put too much heat on the bottom side, you're gonna potentially float the CPU or other components. All right, so it's getting ready to split. I can insert my tweezer here and I can see it moving. So now I'm gonna pick it up and flip it over. So I'm gonna put this down on the side. Hey buddy.
Hi, what can I help you?
Turn on the fan.
Okay.
And let's see. Now, some cases where this will be not repairable and it will be data recovery only is if the Wi-Fi or baseband chips are cracked. Those chips are paired, meaning from the Apple factory, they were paired to the CPU and there's no way to replace them. If the chips die or fail, then it's game over. Now the phone can technically work without them, but what good is a phone with no Wi-Fi or cellular? It's pretty much a camera that you have to transfer data via USB. But I guess it could have some value to someone, but most people do not want that. So those cases will be data only. So like, let's say you took your phone in for repair and you never backed up your data and then they killed the phone. Well, we can help. So send me a message right there at the bottom of the screen. You can see my website, vccboardrepairs.com, and then just go to the contact us and send me a message. All right, so visibly, I actually don't see the common failure. Maybe. This is the chip that commonly fails. I was actually expecting it to look worse. So I'm gonna get a foam swab. What I like to do is clean off all this. Oh yeah, I think I see it. Clean off all this thermal paste because we need to see where is the issues. Oh yeah, I see it. All right, I don't know if you guys can see it. Drop a tweet in the comments if you can see these cracks right here. There's like a line that goes along that way, and there's like two lines at least that go this way. It is cracked. Now, the other potential cracked chip is up here. Now the downside is ZXW does not have the net names for this chip, so there's no easy way to know whether this chip is shorted or not. There are some lines on this chip that you can measure. The meter will beep, but does not necessarily mean that it's shorted. Meaning some lines are low resistance, which will trick your meter into thinking it's shorted, but it just naturally reads low. So meters don't know whether something is shorted or not. It just knows a low reading, and when it detects a low reading, it'll beep. So just keep that in mind. A lot of noobs fall for that trick. They measure something and the meter beeps, and they just automatically assume it's a short. Okay, so let's see. I don't see anything else. Well, let's move on to the next step. Let's see, where is the short located at? Is it on the bottom board or the top board? This helps confirm whether or not I'm correct in my theory that this is the chip. This is the most common failure that I see. And we've been seeing this since the 12 series. For whatever reason, these chips on 12, 13, and even 14s like to crack. I don't know if because they're like that glass or silicone look or what. So right now I'm just taking off the thermal paste off the top board. We're going to clean this off as well. Alright, so there's a lot of thermal paste, but we don't need it. Alright, so start off with the top board. Remember, we had a 2.5 amp short before prompt to boot. Now, short is gone. No short. Now, we can short the power button pin to prompt to boot or plug in a power button. I already know off the top of my head it's going to be one of these pins right here. Yeah, so it's showing normal boot consumption. Now I didn't hold it, so it's not gonna boot. So there you go, it went back to 0. But that's probably fine. Let's not focus on that one. Let's put it off to the side. Now this one, we can't plug this in. This is where we got to go back to using our probes. So this is the one that's connected to our DC power supply right there, right below me. And if we go to ZXW, let's find where is this line at. All right, so here's the chip that's cracked that looks like cracked. And one thing about the 12s, I think even the 11s are like this. Although ZXW shows you as all this in red, meaning they're all the same line, they're actually not. So let me show you kind of a rough idea. It's not exact, but just so you get an idea. You're gonna have 3 sections of VDD main on the bottom board. So there's gonna be like this section here, there's gonna be like this section here, and there's gonna be this section here. So let's go under the microscope to confirm that. All right, so we're gonna measure the different sections of the board and see which one is the shorted section. So according to ZXW, this one here is VDD main, and look at that, 392 is not shorted. We go, let's see, it looks like this one here, 002, a short. That is definitely a short. And then if we go down here, this one here, look at that, not shorted and a different reading. So that tells us that we have 3 different, look, if I probe from here to here, no continuity. From here to here, no continuity either. So here to here is not connected. Here to here is also not connected. Oh, did I touch it? I'll touch the top of the chip. So yeah, these are 3 different circuits, but when you sandwich the board together, they all combine into one. So just keep that in mind. So if you're trying to inject voltage, you got to make sure you're injecting into the shorted section of it. So I can inject here. I can inject here. Let's see where else. There's a... By the way, when you have a short, everything that's part of that circuit will read as short. So just because I'm probing these doesn't mean those are the shorted components. And it's a very common mistake a lot of noobs make as well. They probe something as short and they think that's the short. And then they remove it and the short is still there. Because that is not what was the short. Now it could be, you could get lucky and you accidentally probe the right shorted component, but not always. That's why we need a tool like a thermal camera, which is always linked in all my videos down below. We also are the ones who sell the stand for it. All right, so this is my DC power supply probes. I'm gonna put it in the baseband PMU section. And I need to pick a spot to inject. So black probe on ground, so like the sim tray. So the baseband PMU is here, yep. Let's put that dead center-ish. And then black probe on ground, red probe, let's do this one right here. Oh, my hand, the heat from my hand triggered the camera. Whoops. Oh no. Look at that, baseband CPU is lighting up. That is not good. That might be a game over. All right, that's not good because we're injecting into baseband PMU and that's shooting that voltage into baseband CPU. And I don't think CPU is supposed to, baseband CPU is supposed to get 4.2 volts. And that's already been happening from when the board was in the housing and plugging in the charger. All right, so let's try to remove the chip and see the short clears. What I'm gonna do is I'm gonna set the heater to about, I just need some residual heat, so maybe around 100. And here's the chip. And just remember, oh, you guys can't see that. The text is upside down. So if you can't see, this is PMX 60 upside down. So I can't see the orientation dot from here. Usually in the corner somewhere. Right there. Oh, it's right here. Orientation dot right there. So let's mark it. Oh, what's this? I think that's flux. I'm just gonna carbon X into the shell of this coil or inductor. All right, and then a little bit of hot air as well, so about 250. What sucks about this chip is how tight all the surrounding components are. And one thing I'm gonna do is add my little fingers to help the board, prevent the board from moving. So I have one there and one there, just running across. Because especially when I'm trying to pick off the underfill, the board is gonna want to lift. And you gotta have a really sharp blade, so I'll link to those as well. And I'm gonna show you my secret technique that is not so secret because I made a full video on the technique on how to remove this chip. At least the safest way I found. It's kind of tricky because of how tight space there is around here. And you know what? What I'm gonna do is I'm gonna replace, in this video, I'm gonna replace the chip and then see if the short still is present and baseband works in the jig. If baseband does not work in the jig, then I'm gonna call it quits. At least for the end for this video, because I think I'm not sure if a bottom board swap would fix the short, or the baseband dead, then bottom board swap would not solve it. Like I said, the baseband chip is paired. Baseband PMU, the power chip for baseband circuit, is not paired. Baseband CPU is the brains for the baseband circuit, and baseband is cellular connectivity basically. Now, will this work Wi-Fi only? Technically, will the shop who sent me this have to buy the customer a new phone? Probably. If I can't fix it, and I might have to charge a bench fee if they want me to attempt the bottom board swap as well, because it's a lot of work. I have to also prep a donor board, which means I have to get a iCloud locked iPhone 13 Pro Max, separate the sandwich. Like basically everything I'm doing right now, I have to do it twice, and then I have to transfer the chips from here to the other one, and it's not fun. But we do offer it as a service, especially based on the price we charge for this. So keep that in mind. This is not a cheap repair. Don't expect a few bucks. It's going to be very expensive, but it's doable, and it's going to be cheaper than a new phone. I'll tell you that. But if you guys need this repair, send me a message for a quote. We offer B2B discounts for repair shops. So if you're a repair shop and you ran into this issue, we do give a discount for you because you're a repair shop, and we want to build a relationship with repair shops, so we can be your assistant with any board issues or data recovery, and then you just handle the customers and the shipping back and forth. We handle all the work. If anything, it's a win-win because you don't have to do any work, and you get all the credits and notoriety, and I'm just behind the scenes doing all the hard stuff, but making the most money from the service. Just, I think it's fair trade-off. If you can't do this in-house, don't worry. We are professionals. We have a full process on mail-in repairs. We're not just like, oh, text me. I won't just text you the address and like hope I don't lose it or whatever. It's a legit process for mailing in your device for repair, whether it's a direct end user, consumer, or repair shop. We service everyone. If you're a repair shop, make sure you share your business name, Google address, and all that, and your business email. We can send you our price list as well. And one thing I like to do, because we're going to use heat to remove this as well, is clear out all the underfill surrounding the chips. Not just the chip itself, but the surrounding area. This helps prevent what is called floating, where underfilled components dislodge but potentially stay in place. So they're physically there but not connected in the circuit, causing problems. I'm just kind of going around and pick off all the chunks, underfill. All right, I think I got all of it, or at least most of it. Next is the grinding pen. All right, so here's what I do. The goal is to cut into the chip so I have an opening to lift it up. You could also technically grind away the whole chip. Now this takes some practice to know how much to grind away. Now keep a real close eye on what's being grinded away and what's being exposed. You can only go a certain depth before you destroy the board, which then you'll be forced to do a bottom board swap. I'm seeing surface right there. Then I want to get like an X across. I'm trying to concentrate. Last time I was trying to talk and didn't notice I went too far. Now you guys see the gold or the copper dots? Okay, so we grinded away some of it. So my method is basically a hybrid of a CNC. Grind away a chunk and then find the spot to insert your tool. Let's see, let's try this. I don't know. This is a really tight one. So I don't have too much room to drill or grind away the... You know, let's experiment. This is how I'm gonna experiment with experience. So it's not like I've never done this and I could potentially ruin everything. I've experience with this process, so I'm just gonna try to tweak it. And I did add flux, so let me remove that. So I changed tips. I'm gonna see if I can find an opening with this one. Alright, so it might be a little quiet here because I need to see what's going on. Concentrate. All right, so I think I'm making progress. So I'm gonna grind away some of the thicker parts. The main reason we're grinding it, I don't know if I mentioned it, is it's really hard to lift this chip. It's underfilled. In other words, there's glue holding the chip down, and it's really hard to lift it up. So there's literally no room to insert any tool underneath. All right. All right. Well, I can see an opening. Let's see. Let's give this a try now. This other tip works a little different than the disc type, but let's see. So I have to use high temp 380, and then we're just gonna heat the circles. Then just see if we could scoop up a chunk. Yeah, look at that. I'm getting a little bit underneath. Now I can break off bigger chunks. And this is the scary part because you don't know if you're digging into the board. Well, let's see. I'm getting, yeah, I'm getting in there. And this is stressful because I'm recording it and I could already hear everyone judging. I'm gonna add some solder in here and it can help easing up the job. Now if you guys have a better technique, let me know down below in the comments. I know everyone loves to talk about how their technique is always better than the YouTubers, but here we are. Now one thing I do want to see is, if someone says they have a technique that's better, we'll make a video of it. Oh, look at that. Got a big chunk out. Now don't just say you have a better technique and then hide behind the keyboard in the comments. Make a video of it and show us. Okay, let's see. Alright, basically I just have the bottom side. You know what? I'm gonna unplug the heater so I could reach the other way around. We'll add some more flux. Just go back in. Now, like I said, you should practice on donor boards if you're ever trying this for the first time. I've done a ton of these like grinding method ones on all sorts of chips, so I kind of know what to expect, how to angle my tool and everything to avoid the least amount of damage. So don't just send it, don't just wing it, like I know a lot of you guys do, especially beginners. I mean, if you have years of experience, typically you kind of know what to expect even in new environments, but a lot of beginners just go right in and try a bunch of crazy stuff. You know, it's kind of important to know your limits sometimes. Here we go. Chip is all gone. Where it went? Where it went? That's a good question. I would have no idea. We'll look for it after this. Nice thing about unplugging the heater is it's still going to keep a lot of residual heat there, so that it still acts as a heater, just slowly cooling down. Now, let's say this works in the jig and we get baseband. I think I'm just gonna call the video quits there. I don't want to make this too long. If you guys want to see a reball video, I have several on my channel on how to actually reball these sandwiches. Let me know if you want a specific sandwich reball video, like a certain model that I haven't done. I've done a lot. I have 15s, 14s. I don't think I have a 13. 12 Pro Max. I think that was a 12 Pro Max bottom board swap. Oh no, 12 Pro Max sandwich reball that didn't work, and I skipped doing the bottom board swap. All right, let's clean up and see what the damage is. All right, so I'm gonna use some hot air to clean up the rest of the underfill chunks. I'll make sure to clear all this stuff out. I really get into clearing out all the chunks, maybe more than I should. And it's very therapeutic. Kind of like, I don't know. I'm trying to think of an analogy where you're just like fixated on doing something so simple. Like today I was really enjoying breaking down all the boxes for all the mail-ins. I kind of collected a big pile and I started kind of hoarding a lot of boxes, thinking, oh, I'm gonna need this one day, because I reuse the shipping boxes regularly. I hardly ever had to use a new box, so I just reuse the old ones. So I gotta strategically keep certain boxes. You know, like if I do a lot of iPads, I get a bunch of big boxes. Or a lot of times people ship me stuff in a really large box when it's a lot cheaper to ship in a smaller box, ship it back in a smaller box. But now I'm stuck with this giant box. And so yeah, so I spent like an hour going through every single box I had and checking what devices are in my queue, what boxes I might need, and trying to calculate, hopefully have just the right boxes for every single repair. But also, depending on where you are, if you're like in California, Utah, or Arizona, shipping, even if with a really large box, is going to be cheap. Whereas New York or like South Carolina, since that's all the way on the other end, is not as cheap. So like even just a slightly larger box will affect it by a few dollars. And if I have a smaller box, might as well just get a smaller box. I'll turn on the heater. I'm a wick with my favorite chem wick. Now rotate this. All right, once again, I reached the end of the cord. Well, let's see, maybe I could reach it this way. My iron is also at the end of its cord length. I think I got everything. Okay, let me suck up all the flux. And then we can drop ISO and blow it away. Look at that. Zero damage from the grinding pen, no rip pads, and no bumped components. There is, all right, I'll be honest, there is one cap right here that feels a little loose. But that's a VDD MAIN cap, I think. Oh, look at that. It is loose. And I'll probably solder itself back into place when I install the chip. All right. Now, let's clean up this. Where's those chunks of that chip? Where'd it fly to? Oh, there's one piece right there. This heater has a lot of miles on it, so don't mind the messiness. Okay, so now let's check for a short. So, looking at ZXW on my other screen, just trust me on this one. Oh, oops, tool slipped. No more short. No more short. And just to be sure, we're gonna inject into that same line to show there's no current draw. Now I'm touching the cap, 0 amps. That means the short is cleared. All right, so now let's install a chip and see if we can get, one, check that the short doesn't come back, and two, see if baseband works. After, we also have to prep the sandwich and all that. So I have a brand new chip from Mobile Centrics. They are one of my suppliers, and they only offer this to repair shops. So if you're a DIYer, good luck. They may or may not approve you. Otherwise, you can use in your gadgets. I think they sell to anyone. All right, and take a look. There's like virtually nowhere the chip can even like be misaligned. It's like really tight space. But let's just try to align it. All right, I'm going to use some low heat first to try to install it. This is a PMX60. Remember, we marked an X up here, the dot's right there, and we're going to install a new Baseband PMU. This is a chip repair shops will kill very commonly. So we carry a lot of these in stock because of this reason. So repair shops, please be careful with your backblast tools. Take the board out or don't use it where the board is located. I'm starting low because I don't want to use too much heat when it's unnecessary. Also put a lot of flux. So whenever you put a lot of flux, what you can do is just use low heat to kind of evaporate it. And then what you want to do is bump up the heat once it's heated for a bit, because then the solder joints start grabbing onto the solder pads. Right now, I'm gonna bump it up to 360 from 320 something. And basically it's like in stages. A reflow stage profile. So I can see the way the flux is behaving. I can kind of tell like it's getting hotter, but not hot enough. Let's just go into place on its own, which I think I just did and I missed it. One thing I'll have to do is bump a corner, a tweezer. Now I feel solid. All right, let's go to stage 3. And this should for sure install the chip. You'll see it move any second now. And there it goes. Look, I'm gonna bump it. Now it's pretty hard to bump it anywhere else, so I'm just gonna assume the rest is good. I don't want to float baseband CPU, which is right next to it. You know you floated it when you see a bunch of solder balls sticking out. It's a very common noob mistake as well. They'll bump, they'll float, they'll float this baseband CPU or float anything that's underfilled and then destroy the phone. And now we have to just straight up go to a bottom board swap when it could have been repairable to begin with. So yeah. Another thing is careful who you send your devices to. A lot of noobs out there who are claiming to know how to do this stuff. The reason why I know is because we often get repairs after them, and now we have to clean up their mess. Now there's also a lot of reputable places too, so make sure you guys do your research. Look up their reviews for motherboard repairs. They might have good reviews for screen repairs, but check their motherboard repair reviews. So look in their reviews for motherboard repair or soldering, micro soldering, stuff like this. If all you see is, oh, they did great on my screen repair, then I'd be wary. Also check their pictures, see if they show any soldering pictures in their reviews. Now, right now I'm currently adding 183 solder wire to all the pads because we gotta wick it after. And yeah, I'm getting some on the edges, but it's fine. Not the end of the world. I mean, it doesn't look clean, but the only ones who are gonna care are other techs. This is gonna work if it works. It's not gonna be from that. That makes sense. As long as you wick it flat after, then it's not gonna be an issue. If you leave giant blobs of solder there, then it will be an issue. I'm kind of trying to rush. I'm partially trying to rush through because I want to finish this video. It's way past my bedtime. I always record these late at nights, which is probably not the smartest idea because it's very late. I need to go to sleep. And I do like to just finish it at once versus recording, you know, a section here, section there, because then I'll never finish it. I'm more of a I'm more of a let's just get it over with now kind of person. Which is good and bad. But I'm also really easily distracted. So one of my biggest issues, not big issue, but my biggest struggle is during the day when everyone's messaging me for quotes and stuff. Like it's really hard to get back to work because as soon as I see a notification on my screen, I want to stop what I'm doing and respond. And then I start clicking on other stuff, and next thing you know, it's been 1 hour and I haven't done any work. So I gotta learn to solve that. But also, the fact that I respond quick is one of the things people love about our service. So double-edged sword. Luckily, I do have a employee. He does really good work, and he helps keep the ball rolling while I'm doing a lot of the sales and management of the business side of things. Which reminds me, the other day I posted about someone had asked me like, oh, well, people ask me this all the time, like oh, they see what I'm charging, and they see my videos and like, oh, I could just do this myself and start my own business. Well, it's not that easy because it's not just about the repair skill. It's about a lot of skills in running an actual business. Just learning how to solder is not going to just bring you clients. You got to bring clients to you, and you do that with marketing. And then once you get them to you, now you got to sell them on the service. So you have to convince them to get their wallet and give you money in return for your technical skill that you learn from watching YouTube videos. And that's a really hard part because most people don't know how to sell, from what I noticed, for this type of service. So what happens is they'll get rejected a lot, and they think the only thing stopping them from selling is the price. So they just offer dirt cheap pricing because they don't know how to sell. So there's always going to be people who are shopping on price, so they're going to get those customers, and then not get the rest of the customers who are looking for quality, customer service, stuff like that. And then they say that you can't make money in soldering or repairs. At least that's my perspective and experience. Let me know down below in the comments what you think. Definitely, there's way more to this business than what you see in these videos. If you didn't notice, these videos are a form of marketing. In other words, marketing is to get you to contact me for a service. It's kind of how you promote your service, and then just promoting it is not good enough. You gotta learn to sell. A lot of people don't know how to sell. They're really nerdy. Like I'm a nerd too, but I also have mindful of what it takes to sell the service at a premium for the value that they're getting. A lot of people don't. A lot of people feel like, oh, if I charge too much, I'm hurting the customer. And the sad part is that's not true. Customers are willing to pay. A lot of customers are willing to pay for good service. But you gotta convince them on why your service is so good. That's the thing. You gotta have confidence. You gotta prove your confidence with your reputation, your Google reviews. Part of my reputation is what you see here on YouTube. You literally see my work. If you're trying to sell a service and you have literally nothing posted on social media, how are people supposed to believe you. If you have no reviews, no nothing, then it's going to be hard for you to sell service. Word of mouth is another good way. That just comes with time and experience. This is not an overnight business. I've been doing this since officially 2016, but I've been doing repairs before that as a kind of side thing, and it takes time to build the clientele and all that. So it's not like, oh, I'm gonna learn data recovery and all of a sudden I'm gonna be able to make hundreds of dollars per service just because you learn a skill. No one's gonna want to pay you anything if they don't know who you are or why they should send it to you. So keep that in mind. All right. All right, this is as clean as I can get it. The Q-tip is saturated with flux. Now the other side. Now I hate doing the top side because the board heater has no holder for this. So let's do this. Let's put this one up here, this one up here. The heater helps with prepping the board, and it is the exact same thing. Alright, get flux on every pad. Let's kind of go around that part of the board. Let me get some flux on here now. Now we recommend you rest this on a coil or some caps, not on the CPU. A chip might be fine, but I guess just keep in mind my heater is at 125 right now. Sandwich heater. The reason why you want to add solder to the pads first is it makes it easier to wick after. So let's go through this. So I appreciate everyone who's making it this far into the video. I can already tell it's going to be a long one, but I don't know how long, because I constantly stop. I think I'm at least 2 hours. I don't know, but I do. This job itself is probably like 2 hours, maybe 3, without recording it. When I record it, I am explaining every step in the process, which is more to teach you what I'm doing and why, which takes time to explain. If I don't explain it, then everyone's going to be asking in the comments. So make sure you guys are liking the video if you appreciate me explaining these things to you. Yeah, let's go through here, prep all the pads. This is the boring parts. All right, there we go. Yeah, so let me know down below in the comments, when did you start your repair shop, or are you planning to start a repair shop, and why? I started in 2016 with SoCal Digital Repair in Montebello, California. It was a home-based operation, and now in 2020 I moved to Las Vegas and had to rename because the old name didn't make sense, and I kind of wanted something new. In 2020 I am now VCC Board Repairs, and I'm still home-based. I actually prefer it because I don't have any random customers walking in and interrupting. Any customers that come in are appointment only, so I already kind of prepared for them. And it's just dropouts. I do not allow anyone inside. We just meet in the driveway. So I have a lot of people who like call me or message me saying like they're in Vegas in town and they want to come visit my shop. Well, I don't have one for you to visit, so don't ask. I am pretty busy, so yeah, this is by design. I did not put my address out there for you guys to just come stop by, because I have a lot of things to do. My time is limited, so I choose it wisely. Yes. If I'm not working, I'm with my wife and my dogs. So, because if I'm not with them, I'm working. So, this queue is not gonna clear itself, and the bills don't get paid if I don't work. So I'm here to work. Anyone who knows me knows that I'm always working. I guess it's better than just sitting there watching TV, not doing anything productive. Oh man, I can't, let's skip that spot. What? Let me do this. Because it's kind of hard to reach all those areas. So let me rotate the board. Find the spot where it will fit. There we go. Oh, found the spot and then it moved. And there you go. All right. There we go. We're almost at the end. Drop shiny solder balls in the comments if you're this far into the video. It's I'm gonna guess 2 hours at least. I don't know. Like I was saying earlier, and I think I got sidetracked, is on OBS where I'm recording, it tells me how long the current clip I'm recording is. I stop it regularly to take breaks or whatever, to do something, or just make sure it's not a super long single clip video, otherwise it starts messing up. And yeah, I don't know. I think the latest one is 49 minutes. So I want to hear you guys' thoughts. Do you like these super long videos with very boring menial tasks? Or do you want me to crop all this stuff out? Like all this simple stuff, to only get to the meat and potatoes, so to speak. Comment below what you prefer to watch, and I'll take it into consideration. When I do long videos like this, I do get to talk about other stuff, the stuff that's on my mind. Whereas if I do short videos, then I'm straight to the point, talk about just what I'm doing or why, and that's it. I do make a lot of shorts now, or reels or TikToks, which are straight to the point. So I don't know, what do you guys think about those? To the 3 people who are still at this part of the this deep into the video. All right, I think that's as clean as I will get. Look at that, I found a chunk. All right, so this is a jig that allows us to temporarily connect the 2 layers together so we can test. So we'll be able to see if we still have a short or what's going on. We can even test the baseband features. Actually, let me clean this real quick. So if you were on the heater or whatever, you're gonna have flux on the bottom of the board. So you wanna make sure you clean all that off because it'll get stuck in the jig or it just won't fit. Because the flux is, you know, physically there, so it's gonna block the perfectly cut out shape for the jig. And this jig does support the 5G flexes, so like I mentioned before, you know, some tools don't take into account the 5G flex, whereas this one, I don't know if they did it on purpose or by accident, but I've been able to use every model on here without any issues as far as the 5G flex. And it's pretty wild to me. I hear people who actually remove the 5G flex on purpose to do whatever repairs and then solder it back on after, which is just crazy. Because you could just buy the right tools, which, you know, if you watch my channel, you'll know the right tools. All right, so this is much cleaner now. 13 Pro Max. I'll link to this jig if I can find it in the video description. All right, 13 Pro Max. There's 3 holes right here, so you got to line those up with the jig and then the top board as well. And the key here is to make sure this clicks or presses down like a spring. It doesn't, you need to add some ISO. There you go. So it should bounce up and down like a spring, because there's pins in the black piece, the spacer part, connect the 2 sides together, and then use this clamp, the top side, clamp it in. Now we're clamped in. First test is for a short, so let's turn this off so we can leave it for us as a surprise. Do we have a short? No, short's gone. Now do we have prompted boots? Check the currents, the green number, the amps. Oh, did I touch? There we go, prompted boots looks normal. So we don't have a short before prompted boot or after prompted boots, and I didn't hold that long enough. But let's do this. Let's plug in the screen. Now because this was no power, we have no idea on the condition of the screen, so hopefully it's good. Otherwise, customer is going to be screwed with paying for a new screen as well. All right, short the power button pin to ground. Let's see if we get an Apple logo. You gotta hold it until it jumps up from here. Let go. Apple logo. So if baseband doesn't work, we're gonna call this data only. If baseband does work, then we can reball it and be ready to go. Now the concerning part is baseband was heating up when we injected into main. All right, it's about to boot. Okay. Unlocks. All right. Well, we have Wi-Fi and Bluetooth, but no service. That is questionable. All right. So now let's go to cellular error. So this is a baseband issue. Now it could be the jig. Look at that. Cellular error detected. This is a really weird way of saying you have a baseband issue. So this is not a permanent error. Like if you get this, it's not gonna permanently damage your phone. It's just telling you the baseband is not working. I'm gonna turn this off. I'm gonna try it one more time. because these jigs are not 100% reliable. Back in the day, like 11s and older, the sandwich jigs worked fine. Started on 12, they started getting sketchy. So I'd have a lot of ones that I thought were no fix, because no matter what, I couldn't get it working the jig. And then we reball it and it works. So I don't know if it's the specific Mega Idea or Qianli eye socket jigs or what, but it's weird because sometimes it works and sometimes not, and we can't figure out why. Like, it's like the same model and everything. It just sometimes some devices work, some don't. Okay, so I'm gonna squish it. I put alcohol and then dried it out just to see if that makes a difference. The goal is to make sure we have a good connection between the top and bottom board, because the bottom board, the sandwich pads, is how the baseband chip will talk to the main CPU to discuss cellular topics. So they chit chat about cell phone towers and carriers and SIM cards and stuff. And if they don't have the connection through the sandwich, you're not going to be able to talk to each other. Hold, and let go. Well, good news is at least the screen works and Wi-Fi works. So a customer may be stuck with a Wi-Fi only device. They didn't kill the Wi-Fi chip. And like I said, take a look how beat up this whole section is where the motherboard sits. Okay, we're in. Searching, not a good sign. Should not be searching. No service, searching. Oh boy. All right, well, I will have to continue working on this. I will post my final results on what happens with this case in my locals community. So once that is posted, I will link it in the video description and in the comments so you guys can check it out and read the final results. But at least you guys saw how to repair it if they didn't kill the baseband chip. Also, if you're looking for data recovery, we can also offer it for these type of scenarios as well. So let me know down below in the comments what you guys learned in this video. Make sure you guys are sharing this video as well with all your friends and people who have dead iPhones. And get yourself a t-shirt like this one if you want to support the channel. So I will link to all the good stuff down below. And I appreciate everyone who stayed here to the very end. I'll see you guys in the next one.